Alright, this session we're going to do something a little different. We've got a little tube type audio amplifier here, customer's amplifier we've got to fix. It doesn't work, he said it doesn't work. Hasn't been used in years and years. We've got a schematic for it. That's definitely a help. Parts list. All right. Okay, so what we're going to do is go ahead and check this amplifier out. Got the tubes here. Okay, first thing we're going to do, we have to check this transformer. The guy said the thing smells when it's plugged in. It smells something burning. All right, so what we do is we got it plugged in and we're going to turn it on. And let's see, how do we turn this thing on? Okay, it's on, pulling 4.8 watts with nothing in it. Okay, to me that looks like the transformer is working just fine. We got our little watt meter over here. Okay, this is our electronic fuse box. Everything that we test goes through this electronic fuse. And I've got this now set to, I'm going to set it to about 2 amps and 8 cycles. That means that if we pull more than 2 amps for more than 8 cycles of sine wave, then it'll open the circuit right away. And that way we protect anything that we're doing. And right now, with just the transformer hooked up, we don't have any tubes in it or anything else, we're pulling 4.8 watts, which is just the losses in the transformer itself. For a transformer that size, that's about right. Doesn't look too awful bad. It doesn't look too awful bad. Now, what we're going to do first, we're going to test these filter capacitors. Probably they need to be just replaced arbitrarily, but these are later capacitors. They look like 50s, maybe 60s, not 50s, but 60s. Look 60s or 70s era capacitors. So I'm going to just hook a power supply onto them and see how much current they pull. What we do to test the filter condensers is we don't put any tubes in it, we don't light up the filaments. And that way we have nothing but the capacitors themselves pulling current. So we'll hook negative to ground. All right. And that's coming from the rectifier. That's going to be the high voltage one right there. Now, we've got a power supply over here. This is a current limited power supply that's adjustable from 0 to 500 volts. Okay, we'll turn it on. Okay, at 157 volts, we're pulling only 5 milliamps through the whole instrument. All right, let's take her on out. Okay, there's 200, no problem. 300, no problem. Okay, we'll get a little bit more current. Now, 320 volts, we'll get 10 milliamps. Now, that's going through all the capacitors because it goes through some resistors. They're all connected through resistors. So we have 1, 2, 3, 4. We have 4 electrolytics there that are hooked up. And then we have a couple of them that are the bypass for the cathodes. Okay, those are low voltage. They don't have any voltage to speak of across them. All right, so 330 volts. We are back at 5 milliamps. Okay, we'll go up. Okay, that's 380. All right. Now let's look at it going up. Nope. Your 450 volt capacitors, we're going to have, when we first turn this on, we have 340, we're going to have 385 volts on here. So these capacitors have got to take 400 volts without any problem. And when we get up here to, see, we're starting to increase current, 423 volts. 385, it's increasing, that's 30 milliamps. That's no good. Okay, so those capacitors are not going to take the voltage. They are leaking enough to where they will go bad if we leave them in there. It's coming down a little bit now. It's still, we're asking for it. If we leave them in there, we're asking for it to blow up. Okay, so we're going to do a filter job on it. All right. They're not worth risking it. Not worth risking it. Even though we could probably get away with it for a while, those capacitors will fail. We see some of these idiots that repair stuff. They say, oh, you can form the capacitor. Just hook a variac on there and run the voltage up slowly and you can form them. And they'll be just as good as new. Yeah, yeah, they sure will, won't they? All right, first thing we're going to do, get those high voltage capacitors out of there. 450, 450, 450, 450. Okay. We've got to put these in there neatly. Now we're not going to leave the other capacitors in parallel. If you leave them in parallel, then they're going to leak and they're going to blow out. So we're going to just take each one and we're going to just solder the ground to the ground, and these particular capacitors have the negative connected to the chassis. You want to always watch out because sometimes these capacitors have the negative isolated from the chassis. And you got to keep an eye out for that, because if so, you want to connect it to the capacitor and not the chassis. You get a bunch of hum if you connect it up wrong. See, now these are completely isolated from the original condenser, the capacitor, so we don't have to worry about them leaking. Okay, we got one more to go over here. Okay, that takes care of all of our high voltage capacitors. Now, the volume control. I'm just watching the meter as I adjust it. It's just smooth as can be. You want to always check these things to see how smooth they are. If you see any jumping when you're turning them, then they're dirty and they're going to have to be replaced. But these look good. All right. Okay, this one's bad. Okay, I'm going to put the meter on the resistor. See how it's jumping around? I'm just smoothly turning it. See, it's jumping around there and I'm doing nothing. Okay, what I'm going to do, I'm going to take the cleaner and I'm going to blast it with cleaner. Look how smooth that is. I'm just turning it smoothly. Okay, that's all the way over. Now I'm going to turn it smoothly back. I'm not jumping or anything. I'm just turning it smoothly. See how it just changes just smoothly as can be. No jumping at all. Okay, so the cleaner took care of that one. Okay, that's one of the tone controls. Go to the other one. Okay, look at that one jump around. I'm not doing anything, and it's jumping around. See how it's jumping around? So that one's dirty too. Okay, take the spray, blast it. This spray, this is brake parts cleaner in the red can. You want the red can because it's non-flammable. You get the green can and that stuff it's highly flammable. It'll set your lab on fire. Okay, all right, now I've worked the control back and forth after spraying it, and all right, I'm smoothly turning it, coming down, coming down. I'm just turning it smoothly. It's just as smooth as can be. All right, so those will be okay now. The brake clean is actually dry cleaning fluid. It's the same stuff that's in the dry cleaners when you take your clothes to the dry cleaners. That's what that brake clean fluid really is chemically. It's not harmful at all to your electronics and your wiring and everything else. There's no problem at all with any of it. You can spray that on everything to clean the grease and flux and everything else off of it without hurting anything. Okay, that takes care of that. Okay, now, these are usually pretty darn good capacitors here. I'm going to pull one loose and we'll measure it and see if it leaks. Okay, I'm going to set the meter on a 100K scale. That lets us read up to about 50 megohms. Okay, and I'm just going to get onto here. Okay, about right here is 2 megohms. I'm going to get on that condenser, that capacitor. See, we're less than 2 megohms on it. So it's no good. All right, all it takes is one capacitor in here to be leaky, and we just go ahead and change all of them. If one of them is bad, all of them are going to be bad. So we're going to change these condensers out. Okay, we've got a total of 1, 2, 3, 4. Well, that's a heck of a job. 4 capacitors to change out. Hey, I remember doing that TV set where there was like 80 capacitors. These are the same thing. When you get them at Mouser, go ahead and buy them, bags of 100, and you don't have to worry about running out of them. You can get these, get both types. Get some that are the both ends on the same end, and get some that are the little cylindrical types like this, because sometimes you want the wires to come off the end to string to places, and other times you're going to want them to be in the same place because the wires go right close together, and they're a lot more convenient than having to bend them around. Okay? This one here, actually, both of those will use these. Look at the difference. That's the same condenser right there, but look at the difference in the size. It's like maybe 10-to-1 difference in the size there, volume-wise. Wow. It's the same condenser. Actually, this is a better condenser. This thing is made out of polypropylene, whereas these are just a paper, wax paper. All right. Alright, we got a 100K resistor here. I'm just going to measure it, see that it looks good. Right on the money, okay? Resistors usually are not too bad. They don't go bad a lot. See, I got another one here. Even a 2.7 meg here reads right on in here. Okay. That goes to here. I'm going to measure it just for the heck of it, see if it's good. It's bound to be leaking, but we'll see. That was reading about 20 megs. Even with 20 megs, with a tube-type circuit, 20 megs of leakage is enough to cause problems. You're looking at 400 volts on the plate of the tube, maybe 300 volts, 350 when it's operating, and you're looking at a 470K grid resistance. So if 20 megs is still going to give you several volts of leakage, the leakage voltage will be several volts. That'll off-bias that tube to where it's incorrectly operating. So even 20 megs is too much leakage on these capacitors. Trying to measure 100 megohms or 200 megohms of resistance is beyond the capabilities of most meters, far beyond. Covered with solder. You don't want that thing coming loose later, or you're going to have a callback. If you really want to spend some time, not make any money at your job, you go ahead and you pull all the wires off the terminal, and then you wrap the wire around the terminal, and then you solder it. But if you do that, it's going to take you hours and hours and hours to do even a simple job. And if you're in business, you're not going to make any money. You're not going to do it. You're going to spend all your time fiddling around. Another thing to watch out for when you're doing this, don't wiggle that wire when that solder is cooling. If you wiggle it, that solder is going to crust up and crumble, and it'll break off of there, and you'll have trouble. You'll have trouble. And just little things that you got to do to make sure. Normally the solder cools quick enough to where you don't have any trouble with that, but sometimes you can really get into a situation. Okay, that takes care of the capacitors. Okay? Now, the front end of this is one royal mess. Okay? It is one royal mess. what we're going to do is we're going to rewire this mess. Look at that. Look at that mess that we've got there. Look at this wire here. It goes from right here to right here. Look at that piece of wire they've got on there. And then we got a wire between that terminal and one right down there. They got a big old loop of wire like that on there. And from here, it's down in there, it's about an inch, and they got a big old huge loop of wire on there. And then this one here, this has got to have been a kit. This has got to have been a kit, because the wiring looks amateur. It's got to have been a kit. Okay, what we're going to do, okay, I see a stub of wire hanging out in nowhere down in there. I'm going to cut that off. This is all input circuitry here. You don't leave big pieces of loop and wire and stuff hanging all over the place. You don't do that. You're asking for all kinds of hum and feedback and nightmares. Okay. See this big piece of wire hanging out there? What the heck did they have that on there for? Okay, we'll cut that off. Get rid of that piece of wire there. And this goes back down inside here and connects right back where it should be. Direct connection. No big long loops of wire. Okay, I'm going to get down in here and tin this up. Another thing, whoever did this didn't clean the solder connections after they were done. They just left them there. They look like they're corroded up. They're not corroded. They're okay, but they sure look like they we got a white powder on them, which is typical of not cleaning them. Okay. Now, that's just a nice direct connection. Okay, now look at this one here. That big piece of wire there going over there. Why? Why? Ah! Okay. Okay, we got rid of that much wire. We don't need that. Ah, don't want it. Don't want that wire on there. Okay. Okay, that goes right there. Now, you can see how direct that connection is now, instead of that big old loop going around there. Okay, now this one here that we took loose, that goes right straight to it, so I'm going to cut that. We don't need that much wire in there. What's that in there for? Look at that, big piece of wire, 1.5 inches long, junk. Get it out of there. Okay. Back in there, just one straight little sharp piece of wire right in there. Okay, that takes care of all that. Why do they have that in there? Look at that piece of wire. That's almost. Oh my God! Look at that. That little bit of wire, and they got. Look at that piece of wire they got in there. Oh. All right. Put that right in there. Put that right in there. Straight over. You don't want extra wire on your input circuits on an audio amplifier. It picks up hum. It looks a hell of a lot better already. But what's this? What the heck is this? Okay, for some reason they put a small choke in the series with this 1 meg resistor here. I have no idea why they did it. It's not in the schematic, so out it goes. Looking at the value of the inductor and the value of the resistor, the inductor is going to have no effect whatsoever. Okay, the tubes all test like new. Goo down in it. Let's see what we got here. All right. Even though this is a small box, it's got an ass-kicking speaker in it. It's got a magnet in there that big around. A huge thing. That looks good. Okay. All right, that'll work. That'll work. We'll use a radio. Okay. Oh, come on. Yeah, it does.
Free time. Do you think that's a coincidence? The man who
Radio right there. Okay, we're ready to go. Now, I'm going to turn the power on. Okay, we're drawing 50 watts, 40, 36, 33, warming up the tubes. That ain't worth a crap. Okay. Now, they said there was something like that going on, so let's see if we can find out what it is. Alright. Okay, let's just see. How about that one? Whew! It is a blocking oscillator. Okey-doke. None of these have... We've got... Okay, the feedback, we got the feedback here. When I remove the feedback, the oscillation disappears. So there's something to do with the feedback. What we probably have got is we have a bypass capacitor on the cathode of this stage. Okay, the feedback will be negative feedback to this tube, but it'll be positive feedback to this tube. Therefore, they have a big capacitor here, which bypasses that one to ground, keeping it from getting there. So if that capacitor is lost value, which it could, you know, it's one of those electrolytics, normally they don't, but they can, then that would allow what's happening to happen. So let me get another 100 mic capacitor and connect it in there, and we'll see if that solves it. 100 mic. That ain't gonna stick. Ain't gonna stick. There we go. Stick. All right, power on. Okie doke. Well, wasn't that capacitor? Okay. I'm looking at the signals on the scope. We got on the top of the volume control. We've got real good signal. It looks real clean. What I suspect is the transformer is incorrect polarity. Well, they've got that. They got those. They got the wires hooked up backwards here. That ain't going to do anything for what we're looking at. What they had was the 4 ohm and the 8 ohm hooked up backwards. They may have even more of it hooked backwards. I can't get that from here. That's not going to reach. I need a little piece of wire. It's not unheard of to have a mismarked transformer where the 2 wires are switched. Okay. All right, so that's what it is. The brown and the blue wires are switched on that transformer. Okay, so now we've got the correct feedback. Now we're going to find out why. Okay. All right, that capacitor is bad. Okay, let me get this one in there. Okie doke. It is bad. Okay. That. All right. Okay. All right. All right, that's all good. Now, we've got that other one. All right, let's try again. Let me just get a tone and follow it through. Well, that's good. Hey, my damn speaker's blown out. There we go. I'm looking at the scope. We got voltage. I sure isn't putting anything out on that speaker. This speaker, something happened when I was pumping it through there. I don't know. Yeah, all this junk I've got, that gummy speaker out. I don't know how. What next? How can you blow a speaker like that out, huh? That's a butt-kicking speaker. But it's not making any noise when you put signal on it. It's not working. That's 12 volts on that speaker. I tell you, that speaker is blown out. It is blown out. Oh goodness. Good shit. Boy, that big cone moves like hell. I see what it is. I see what it is. The big cone is blown out. See, these two are good right here, but the big one, the main woofer cone is burned out. All right, let me go look in the attic and see what else I got. I'm gonna get one to go. All right. I had another one. Up in the attic. Close to 100 degrees outside right now. No Houston July summer. .30 in the afternoon. Where my kitty is, she's out there in it somewhere, probably under a house somewhere, trying to find a cool spot to lay. Okay, now we're back in business.
If you're content to say, well.
All right, that's radio. Okay, tape is this one. There's something wrong there. Okay. Tape is that one. Okay, nothing. Okay. Okay. We're missing 2 resistors. Okay. We need 2 22K resistors. I'm going to make it match the schematic. I'm not going to reason out anything, why they did anything. Okay, 22K. I see what they did. They changed this. What they did, there's a preamplifier, and what they did was they changed it to where the input for the radio and the other went through the preamp. The original shows the radio and stuff, which has a higher output than the phono, going through just the first amplifier, the main amplifier. They didn't put it through the preamp. Okay. Okay. Now we've got all of this wired exactly the way the schematic shows. There was quite a bit of it that was, who knows what they were trying to do. It looked like they got rid of the phono equalization. They have equalization here, and it looks like they just took all that and just cut it out of there for some reason. Maybe they weren't interested in hooking a phono onto it, but it's all back in, and just like the schematic. All right, let's hook it up. Okay, we got the new speaker. I've got a new speaker put in here. The one that burned out is going, I'm going to take the big old magnet out of it. It's got a real nice magnet on it. That big old fat magnet on there, I'm going to take that off there and save it, but the rest of it goes in the trash. Ah, no, it's old cheap stuff. Okay, now let's see. Turn the power pots. Okay, tubes are lighting. Signal generator on. All right, now I've got it on tape. All right. All right. Radio. Okay. And phono 1. Let me turn it down. Okay. Okay, and then this is phono 2. Okay. Okay, well that wasn't that big of a deal. Okay, now, it was a lot of work rewiring it, but other than that, it's nice and reliable now. Okay, we put that cover. Alright, since we've got this little amp here, why not measure the distortion of it? Let's see what distortion we get out of a little tube amp like this. Here we have a spectrum analyzer that is used for measuring harmonics and stuff that come out of amplifiers. This one here covers up from 0 to 25 kilohertz, the audio frequency range. It's made expressly for doing audio. Okay, first we're going to go ahead and we're going to measure the amplifier with the load connected to a power resistor. This is a 7.5 ohm power resistor. That's close enough to 8 ohms where it'll do fine. And we got our 8 ohm connection hooked onto there. Now this is not a speaker. This is a power resistor which presents a solid, non-reactive load to the amplifier. It's the best case for the amplifier. We're going to hook a speaker to it in just a minute and we'll see what happens. Okay, right now I have got only the signal generator hooked straight to the analyzer. For the first test, we're going to measure from 1 kilohertz to 10 kilohertz, and we're going to see what the distortion is. We'll go ahead and set it to lower frequency in a minute. Okay, the start, I have the signal generator set right at 1 kilohertz. If I vary the signal generator, that's 2 kilohertz. So it moves it up by 1 division. It's 1 division per kilohertz on here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 all the way up at the top. Okay, I'm going to set it back to 1 kilohertz. Okay. And we can see we have 10 dBs per division for our sensitivity. So our input signal is 10, 20, 30, 40, 50, 60, 70 dBs referred to the noise level. So we look at our third harmonic and we're 10, 20, 30, 40, 50. We're about 55 dBs down on the third harmonic. That's straight from the signal generator. Okay, now what we're going to do is we're going to now put the signal generator into the amplifier, and then we're going to take the output of the amplifier and connect it to the analyzer, and we'll see what the amplifier does to our signal. If the amplifier was perfect, then it should look just like this. If it's not perfect, then, well, the amplifier is doing something. All right, we'll unconnect the input, and we'll connect the amplifier to the input, and we'll connect this onto the input of the amplifier. Okay, and I'll set that to there and turn on the amp. Okay, let her warm up. She's warming up. All right, there it comes. There's our signal. Wow. It's not too bad. Look at that. It's not too bad. Okay? Okay, see, as I bring the signal up, see, I'm bringing the volume up, and as we bring the volume up, we start getting some harmonics. Okay? Alright, I'm going to go ahead and I'm going to measure the voltage across the power resistor and see how many volts we get, and we can calculate how much output we get before it starts to distort. But we can see that up to that level, see, the input signal is at 70, right where we had it before, and we still have the low harmonics. We have a little bit of the second harmonic coming in that we don't have from the generator, so it has some distortion. But we're still, that's 60 dBs down, which is a very good signal. But let's see what kind of power we're getting. Okay, I'm going to take the meter, and I'm going to measure how many volts we have across the resistor. Oh, it's hardly anything. It's a half a volt. Oh, that sucks. Okay, let me take it up. Okay, here is 2 volts. Now we're getting a little bit of distortion. Okay, let me go up to, that's 3 volts. All right. There's 4 volts. Oh, look at that distortion. Okay, 4 volts. Okay, E squared over R, it would be 16 over R is 2. So we're getting 2 watts. We're getting 2 watts out of it, and we're getting that much distortion with only 2 watts output. Oh my gosh, what a mess. Oh, That's only 2 watts. Okay, let's see how much more it'll put out. Okay, that's 4 volts. There's 5 volts. 6 volts. 7 volts. Okay, that's 8 volts right there, RMS, across the resistor. We're getting 10% distortion. That's 10 dBs down, so we're getting 10% distortion with 8 volts on it. Okay, with 8 volts, 64 divided by 8 would be 8 watts. That's 8 watts of output, and we're getting 10% distortion. So we can see that something for a solid-state amplifier would be absolutely nothing. It would be no problem for a good solid-state amplifier to put out 10 watts and have less than 1% distortion. But here, we're getting 8 watts output, and we're getting 10% distortion. Oh boy, people who like tube amplifiers, I guess they like the distortion. Oh well. Okay, let's take the same thing and we'll redo it. This time we're going to do it with a speaker connected to it. This is going to get connected here. Let's bring the power up. All right, I'm going to watch the voltmeter when I do it. Okay, I'm going to set it to 1 volt. Okay, there's 1 volt. Okay, that's about the same as we had before. Just it was down about 50 dBs with 1 volt. That's very low output power. Okay. There's 2 volts. There's 3 volts. That's getting messy. Oh. 4 volts. That's 5 volts. That's 6. That's 7 volts. That's 8 volts. So it's about the same with the speaker on it. It could be that that speaker is a particularly good speaker. All right? Very interesting. All right, let's take it and set it, and we'll go at the lower frequencies. That's from 1 kilohertz to 10 kilohertz, where most of your music frequencies land. Let's go in the range from 100 hertz to 1,000. Okay, I'm going to set the generator to 100 hertz, and we're going to set the start frequency. I'm setting the start frequency right here. It's 90. Okay, 100 hertz. Okay, and I'm going to set the division 50, that would be 100, 200, 300, 400, 500. Okay, we'll go one more. Okay, that's 100 per division. So we're going to start at 100, and then 100, 200, 300, 400, 500, up to 1100 hertz. Okay? Now, the generator, there's our 100 hertz. Okay? Let me see how much we can get out of it. Oh yeah. We got plenty of signal coming out of it. Okay, let's turn it up and see what happens. Okay. Okay, there's 1 volt output. Okay, at 200, we're getting the second harmonic pretty bad, and you know the generator has no harmonics at all at that frequency. I mean, they're just, you know, it's just down there in the mud. So we've got almost 30 dBs of trash in there on the second harmonic at 200 hertz, and then down about 20 dBs at 300 hertz. Okay, let's go up a little more. Okay, here's 2 volts output. It's getting really trashy. So we can see this amplifier at low frequencies is pretty messy. Okay, that's only 3. No, that's 2 volts output. Okay, here's 3 volts output. Look at the number of harmonics we've got coming out of there with only 3 volts. That's very few watts. Here's 4 volts. That's 5 volts. See, right now at this frequency, with only 5 volts on it, we're getting just as much distortion as we were getting in the kilohertz range with double that when we were up at 8 volts. Okay, let's see, keep going. All right, here's 6 volts. Seven volts. There's 8 volts. That's about the same. Okay, at 8 volts, we're getting about 10% distortion. But look at the rest of the harmonics here. It wasn't that bad at the higher frequency. Okay, we can get more out of this. Okay, there's 9 volts. That's it. So at this frequency, 100 volts, 100 hertz, we can get 9 volts out of it, which is 81 divided by 8, about 10 watts. That's 10 watts coming out of the amplifier right now. So we're getting 10 watts output. But look at the distortion. Oh my goodness. Okay, it's just interesting to see what a tube amplifier would do. I don't have a good solid state amplifier to compare. The biggest power amp I have is a 1/2 watt solid state. It's just a general purpose. Okay, that's it. So we see what the distortion is of a nice little tube amp, probably 1970s type of circuitry